In this section you will see all projects you have worked on. Here we can start new project. Let's start a new project by giving a name for your project. Then select the source type of code that we want to analyze. Finally, upload the source code. Here we are uploading the jar file of Sweet Home 3D. The tool now analyzing the source code and extracting the caller callee list. Then, constructing multi-level call graphs. The current graph is the most abstract level of the system. Each node represents a package, and arrows represent the dependency between these packages. The color of a node is assigned automatically based on the namespace of the node. Let's click on this button to view the other levels of the system's call graph. As we can see, beside package call graph we have class and function call graphs. Before viewing the other levels, let's explore the current graph. If you click on a node, a panel shows up with information about the current node. The header of panel contains the name and the namespace of the node. By clicking on Dependent tab, you can see all the packages or nodes that are called by this node. Also, clicking on Required tab, you can see all nodes that need this node. Clicking on one of the listed nodes will highlight it. Also, you can move the node. Zoom in. Shows its information. Center the call graph. Or zoom out. When you click on Dashboard button you will see some statistical data about the system and its current call graph. Also, a table contains all nodes with advanced filter search box. Let's try to get only the entry points in the current graph. As we can see, we got 2 entry points. Clicking on package name will show its information. Let's explore a different level of the system. For example, we will explore the function call graph by clicking on I icon. A new tab opens, so the user can switch between different levels easily. Let's see how many nodes and edges the function call graph has. To explore a certain area in the graph, just put the mouse on this area and scroll up to zoom in. Here we see a node with triangle shape. A node with this shape called an articulation node. Remove it will disconnect the graph. The namespace can tell us the class and package that this function belonged to. To represent the call graph in multi-level abstraction, based on clustering execution paths, we need to execute all the listed processes. Click on this button will execute the process. The user will be notified when the process completed. Let's execute them all. As you can see, the status of process changed to true, and the user can download the resulted file of executed process. Let's view the result of hierarchical clustering by click on the I icon. The result can be represented in 2 views. The current view is force-directed graph view. The results of hierarchical clustering are usually presented in a dendrogram. To change the view to dendrogram, just uncheck this option. Let's choose one of clusters and see how we can map it to the call graph. For example, we select the cluster 62. Let's go back to our graph. By entering the number of cluster in the search box, we can see the highlighted call graph that represents the cluster 62. All paths that are joined to this cluster is listed here, as well as nodes. We can download the cluster and work on it as a separate project. Let's go back to the main page and create new project for the cluster that we have already downloaded it. Select GML as source type and upload the graph file. Now we have subsystem call graph that we can explore. Since the package call graph can be easily understood, we can uncourse or map the current graph to a low-level or finer-grained graph by click on this button. The result of this process is a function call graph that is more specific to certain domain. Comparing the uncoarsening function call graph to the original one, we see the number of graph nodes decrease as well as its edges. If the current graph is difficult to understand, the user can apply clustering on the current function call graph or course the current graph to class level and cluster it.